Hey everybody. Today I'd like to talk about what I remember from reading the biography of Schrodinger. I think Walter Moore was a scientist, so he had a better understanding of the work that Schrodinger did. So let me summarize the points in the book that I find the most interesting. So Schrodinger was really bright as a kid and would understand things really quickly. So whenever something new came, he caught things quite quickly in his mind. When he started to take a physics curriculum, he chose experimental physics in the beginning. So his researches were related to crystals, if I remember. He was tinkering with measurement tools, and he needed to calculate the uncertainties that we usually do in the laboratory. When we use a measuring device, it would have some kind of percentage of error. So he was aware of the limitations that measurement can. His later paper on wave mechanics was an approach in quantum mechanics that was different from Heisenberg's MT. But he started in the laboratory doing experimental physics things, researches, and he wrote a few papers that had mistakes in them, but he still believed in himself. Like, even though you write a paper and it's not completely correct, there could be some insight in it, some techniques that you used, or some ways of looking at it that might be fruitful for other researches. And there was, what I remember is it's been a long time since I read the book, so I'm just telling you what came to mind. So I'd like to add that before he went to war, he wrote a paper that was quite interesting because it had some kind of connection to his paper on wave mechanics. So before he went to war, he tried to describe an array of points that could be symbolized by atoms, and he tried to obtain the equation of motion for each of these points that are separated by the same distance a, and that they have a spring-like force as they move away from their distance a. They have a spring that's similar to Hooke's law, so the force is proportional to how much the different points are separated from each other. And he tried to obtain the equation for a elastic, so a macroscopic object, and he made the distances between those arrays of points closer and closer, and tried to apply this simple Hooke's law and see that if in the limit it would yield the continuum elastic equation, so the macroscopic equation. There was this view that we weren't sure if the world had a kind of hidden microscopic reality such that the amalgamation of the small microscopic phenomena yielded the macroscopic phenomenon that we perceive. There were people like Mac who thought that perceptions were more fundamental than the physical models, and that the physical models of the atoms were not actually real. They were just images to simplify calculations. And so Schrodinger tried to see if the two views could actually be put in correspondence so that perception were actually derived from an underlying atomistic behavior. And so he arrived at the conclusion from his paper as he was trying to make the array of points closer and closer following the elastic Hooke's law. He found that quantities that we measure in macroscopic objects like strings or elastics, they can be put into correspondence with his point-like model only if we measured the average of a collection of points, of a collection of molecules and atoms. So he arrived at the conclusion that all this information that we get macroscopically, like in the big world, the big objects, they are actually obtained by taking averages over all the millions, billions of particles that compose them. Later on, he had to go to war. I think that was in the middle of his